Okay, EIGRP, like OSPF, also support authentication. Okay, authentication means both the two routers, they will need to authenticate to each other before they send the EIGRP packets, and exchange their routing packets. Okay, so the method to protect this, in case there's another hacker who try to connect to the router. Okay, so this is a hacker router. If the hacker router try to connect to the router and try to get routing information, we want to protect it. How do we protect it? We can use the MD5 authentication. So MD5 authentication is used to prevent hacker router from connecting to your EIGRP network and get all the routing information from your EIGRP network. Okay, so the process is actually quite similar to OSPF. Okay, so the first step is to create a key change. Okay, the key chain, and then create a name for the key change. And then now you can have multiple keys. Okay, you may need at least one key. Okay, this key is actually your encryption key. Okay, so you need at least one key. Okay, you can have also multiple key. Okay, so in our example, we just use one key. Okay, then you go to the interface. Okay, and then say I want to do MD5 authentication. Okay, using this command. And then you need to tell EIGRP to use which key. So go to IP authentication keychain EIGRP, the AS number, followed by the name of the keychain, which is the name that you specify here. Okay, let's look at one example, which is easier. Specify the key chain. Okay, this is the name of the keychain. Okay, you can say EIGRP key. You can use any name that you want. Okay, so the most important thing is the name that you specify here must match here. Okay, next, we create the first key number 1, and then key string, and this is the secret key, or the encryption key. Okay, then you exit from the keychain and then go into the interface where you want to enable authentication. So then you run the command IP authentication mode EIGRP, the AS number, which is AS1. Okay, followed by MD5. That means we'll use MD5 for authentication. Then IP authentication keychain EIGRP1, and then EIGRP key, which is the name you specify here. This is to tell the interface to use the key inside this keychain for authentication. Okay, then you can use the same key for the other interface also. Okay, so run the same command for the other interface. Okay, the most important thing is the keychain that is specified here. Okay, on this router, let's say R1. Okay, you must also create the same keychain in R2. Okay, then they will be able to authenticate with each other. Okay, so the urgency will only be formed when both connecting devices have configured authentication and the key matches. Okay, so to verify that if your authentication has been set correctly on both routers, okay, make sure just do a show IP EIGRP neighbors. Okay, then you make sure that both the routers are able to form neighbors with each other. Okay, then this means that authentication has been successful. Okay, the last part is on troubleshooting EIGRP. So some simple steps on troubleshooting EIGRP and the common problems. Okay, these are the commands that you can use for troubleshooting EIGRP. So show IP EIGRP neighbors, show IP route, show IP protocol. Okay, so IPv6, just replace the command IP with IPv6. Okay, the step in troubleshooting EIGRP also similar to OSPF. You can look at the neighbor table. Okay, you can look at the routing table, and also look at a routing table of a few routers to make sure that the traffic takes the correct path. Okay, so the steps are actually quite similar. So these are the commands you can use to troubleshoot your EIGRP if it's showing some problems. Okay, of course, the first thing to make sure that is to make sure that both router can form adjacency. Okay, so make sure that the interface is up and you can ping each other. Okay, so make sure your directly connected interface between the two routers you can ping. Okay, before they can exchange any EIGRP packet with each other. Okay, you can also verify your EIGRP parameters. Okay, make sure that they are configured in the same AS number. Okay, remember for OSPF the AS number can be different, but EIGRP the AS number is important. They must be the same. So running this command, okay, for IPv4, for IPv6, this command, okay, can help you to check the AS number. Okay, also make sure that all the interfaces are participating in the EIGRP network. So the network command that you run, okay, make sure that you have included all the interface in the network commands. So you can check by doing a show IP EIGRP interface. Okay, these are all the interfaces that are participating in the EIGRP. That means you are advertising the network connected to these three interfaces and then sending out the advertisement to the neighbors. Okay, passive interface. Okay, remember passive interface? Okay, so if this is connected to a switch and it's connected to PCs, okay, all these are PCs. Okay, you can set this to be a passive interface. That means do not send EIGRP packets to this interface, because you know that this interface do not have any routers, so there's no need to send EIGRP hello packet or update packets out of this interface, as compared to this interface which is connected to another EIGRP router. Okay, so but sometimes you may configure wrongly. If you configure this as a passive interface, then you cannot form neighbors with this router because it's not sending any hello packet out of this interface. Okay, so check that if you have configured the correct passive interface, do a show IP protocol. Okay, when you do a show IP protocol, this shows you the passive interface that is set for EIGRP. Okay, so as I mentioned earlier, passive interface commands can stop both outgoing and incoming routing updates of that interface. So for this reason, router will not become neighbor if you set the passive interface on the wrong interface. If you set it here, both these routers cannot form neighbors. Okay, so this is one example where you set the passive interface on serial 010. Okay, and notice when you do a show EIGRP neighbors, okay, you do not form any neighbors at this interface. Okay, so the neighbors are only formed on these two interfaces, but not on this interface. Okay, missing network command. This is one common problems. Okay, so if this router have a few networks, 3 networks, make sure you have network command for this network, and these 3 directly connected networks. So if you forgot to put one particular network, or you configure wrongly the network in the network commands, okay, then you will not be able to reach that particular network. Okay, so if you have a missing network, okay, go to the router, okay, check, okay, all your networks are configured there. Do a show IP protocol, make sure all your networks are there. If there's any missing networks, okay, then put in the network command. Okay, let's say network 10.0.0.0 is missing, okay, from here. Okay, then put in a network command to put it back. Okay, to make sure that you advertise this network to the other routers. Okay, lastly is on auto summary. Okay, auto summary may create some problem, especially you have this conduit network. It will cause inconsistent routing. Okay, for example, let's say you have these 2 routers connected to each other. This router is connected to 10.1.1.0 network and also connected to 10.1.2.0 network. And suddenly you have a 10.1.3.0 network on the other side. And these 2 links are connected using the 192.168.1.0 network. Okay, then this will create a problem because your network are not contiguous. Okay, they are disjoint. If you have this kind of network, you should disable auto summary. Okay, unless you are sure that your network are designed very well and all the network are on one side. Okay, they are not disjoint. Okay, this is for IPv4. For IPv6, not much of a problem because they do not support auto summarization. Okay, you must use manual summarization for IPv6. Well, that's all for this chapter 10 on EIGRP. Okay, so if you have any question, feel free to email me and I'll try to explain further on any doubts that you have for this chapter.